Not that I know. All right, let's begin the exam review for Math 3. This is the first set of videos is covering the material from Test 1. Okay, first problem. It says simplify the expression using the distributive property to remove any parentheses. So we're going to multiply the 5/3 times the 6x and the 5/3 times the negative 18. So this is going to be 5/3 times 6x minus 5/3 times 18. 5/3 times 6x is 10x minus 5/3 times 18 is 30. These are not like terms. Whoops, pretty bad with that there. Let me try that again. Excuse me. That was 10x minus 30. And not like terms, so this would be the answer. Okay, you can't do anything more. With problem number 2, we cannot subtract first. Remember, you always want to follow the order of operations. So the first thing you're going to do is distribute with the negative 2. So this is going to be 5 minus 2 times 4y minus 2 times negative 6. That's distributing. So this is going to be 5 minus 8y plus, because minus times a minus, 12. Collect your like terms here. We do have like terms with the numbers, so that's 17 minus 8y. And this is all you can do with it. Okay, problem number 3 says solve the equation if possible. If not possible, write no solution. So with this particular equation, remember we're always trying to get the x by itself, so we're going to subtract 5 from both sides. So you get 2x equals 17 minus 5 is 12. Divide by 2, so x equals 6. And you could check that by plugging the 6 back in for the x in the original problem and verifying. For example, as a check, take your original problem, replace the x with what you said you thought the answer was, which is 6, and follow the order of operations. So multiplication first, followed by addition, and you see that 17 equals 17, so it checks. Okay, problem number 4. Solve the equation if possible. If not possible, write no solution. Okay, the first thing you have to do is clear parentheses by using the distributive property here. So bring down the 3x. 6 times 2x is 12x. 6 times negative 3 is negative 18. And just bring down the other side. There's nothing to do there. Now look at the left side of the equal sign. You want to make sure that you collect any like terms. And you see that we have like terms here in the x's. So 3x plus 12x is 15x. Bring down the minus 18 and bring down the rest of the problem. Now you have variables on both sides. So remember, we want to bring the variables to the left and numbers to the right. So what I'm going to do here is we're going to add the 7x and line it up with the x, the like terms. They'll cancel from this side and you get 22x. Bring down the minus 18, bring down the equals, bring down the 4. Now we want to get rid of the negative 18, so we want to add 18 to both sides. So 22x equals 22. And then of course you want to eliminate the 22, so divide, and you get x equals 1. Okay, another equation to solve. We've got parentheses, so we want to use the distributive property to clear that first. So 5 times 7 is 35. 5 times negative x is negative 5x. All over 2 equals x. Now, if you don't like denominator here, you don't like fractions, let's get rid of the fraction. So let's multiply both sides by the common denominator, which in this case is 2. And that'll eliminate the 2's here to leave just 35 minus 5x. And x times 2 is 2x. Now what we want to do is get the x's on the same side. So this time we can go ahead and bring the x's to join the other x over there. So I'm going to add the 5x to both sides. So 35 equals 7x, and I'm going to divide by 7 so that I can get the x by itself, and x is 5. And once again, you can always check your answer by replacing it back where the x's are. Okay, so we have another equation to solve with fractions and parentheses. So the first step is always get rid of the parentheses by using the distributive property. So that's going to be 5y minus 20 divided by 3 equals 2y minus 2. And just like with problem number 5, we want to clear the fractions, so multiply through by the common denominator. In this case, that would be 3. So you're multiplying both sides of the equation by 3. The left side, the 3's will divide out, leaving just the numerator, 5y minus 20. The right side you will distribute, so you're going to get 2y times 3 is 6y, and negative 2 times 3 is negative 6. This leaves you a variable on both sides type of problem. So once again, we're going to bring the variables to the left, numbers to the right. So I'm going to subtract 6y from both sides. Notice how I'm lining it up under the like terms. They cancel here, so 5 minus 6 is negative 1y, which is negative y, minus 20 equals, this is negative 6 over here, don't forget the sign. And now I want to clear the minus 20, so I'm going to add 20 to both sides. Bring down the negative y equals 14. Can't leave negative y, and remember that's just a negative 1 in front, so I'm going to divide by negative 1. And y equals negative 14. Okay, here's another complicated equation to solve. Remember step 1, get rid of all of the parentheses using distributive property. So this first one's going to be negative 2x plus 14. Bring down the 5x and distribute the negative 7. So that'll be negative 7x minus 7. Bring down the plus 21. Now look at each side of the equal sign to see if there are any like terms to combine. You'll notice on the left side there are no like terms, so we'll just bring it down. On the right side we do have like terms, so 5x minus 7x is negative 2x, and negative 7 plus 21 is plus 14. Okay, now what we want to do is bring variables to the left, numbers to the right, so I'm going to add 2x to both sides. And you will notice that the variables cancel out on both sides, so now what you have left is 14 equals 14. Well, this is one of those special equations that you either have no solution or, remember, it could be all real numbers. Based on what's left over here, this is true. It will always be true no matter what the value of x is. So the answer to this is going to be all real numbers. If it were a false statement left over, for example, 0 equals 14, that is never true. That would be a no solution answer. But in this case, it's all real numbers.